Imagine waking up on Mars, grabbing your morning coffee, and then jumping on a transport to another planet just a few days later. Sounds crazy, right? For decades, our entire mindset around space travel has been totally dominated by these massive billion-dollar single-use rockets. We build an incredibly complex machine, blast it off the Earth, and discard most of it in the process. It's highly inefficient, it's incredibly expensive, and frankly, it severely limits how far and how fast humanity can expand. But what if we replaced that model entirely? What if, instead of massive one-off launches, we had a stepping stone transport system? That awe-inspiring vision is exactly what we're going to break down today. Okay, let's dive into this. We've got 5 key areas on the agenda today. 1. The space hopper vision. 2. Powering the deep space leap. 3. The invisible radiation threat. 4. Shielding the human crew. And 5. Humanity's cosmic insurance policy. Let's get right to it. Starting with Section 1, the space hopper vision. Let's look at how we actually transition from our current heavy launch paradigm to a fully connected cosmic network. So, what is space hopping exactly? It's basically the creation of a permanent transport network. Think of it way less like a one-off Apollo mission and much more like a cosmic bus route. This network utilizes reusable spacecraft, orbital fuel stations, bases on the moon, and even outposts on asteroids. Instead of hauling everything you need from Earth's surface for every single trip, these space hoppers just live in space. They travel efficiently between planets, moons, and established colonies, refueling while in orbit. Once this infrastructure is built, traveling through the deep black of space could eventually become as routine as flying between countries here on Earth. And here's the why behind all of this. Hundreds of millions of dollars. That staggering number is the price tag for just one traditional rocket launch today. It's astronomical. Every mission requires massive amounts of fuel, equipment, and complex logistics, mostly just to break free of Earth's gravity. But by establishing field stations in orbit and reusing ships, we totally bypass that massive initial cost for every deep space journey. This is exactly why the reusable rocket technology we've seen proven by companies like SpaceX is so foundational. Proving that rockets can land and fly again, rather than being trashed after one trip, is the absolutely crucial first step to making the space hopper network a reality. It fundamentally slashes costs and kicks the door wide open for real deep space infrastructure. All right, Section 2. Powering the deep space leap. We know the route we want to take, but how are we actually powering these cosmic buses? To pull this off, we absolutely have to ditch traditional chemical rockets. The incredibly smart folks building this network are zeroing in on 2 breakthrough propulsion technologies. On one side, you've got ion engines, which offer extreme high efficiency through an electrical push. On the other side, nuclear engines, which provide raw, massive speed and can literally halve our travel time. Let's break down the actual mechanics of how these 2 vastly different engines work to push us through the void. First up, ion engines. While standard rockets rely on violent chemical combustion to generate thrust, ion engines take a totally different, super efficient route. They use electricity to ionize a neutral gas, something like xenon. Then, they use powerful magnetic fields to accelerate those charged ions out the back at mind-blowing speeds. Now, the physical push you get at any given moment is tiny, but in the frictionless vacuum of space, that continuous, relentless electrostatic push builds up massive momentum over time. NASA's testing already proves they possess incredible fuel efficiency. For a space hopper hauling cargo or traversing massive, long-distance routes across the solar system, ion engines allow ships to go incredibly far while carrying just a tiny fraction of the heavy fuel a chemical rocket would need. But what happens when you've got actual human beings on board? Well, that brings us to this number, 7 months. That is roughly the standard trip time it takes to crawl from Earth to Mars using conventional rockets. 7 months trapped in a small metal tube. This is exactly where nuclear thermal engines step in. Instead of just burning fuel, a nuclear reactor generates immense heat. That heat expands a liquid propellant, usually hydrogen, and blasts it out the nozzle to create massive thrust. This tech could literally cut that 7-month Mars trip nearly in half. Astronauts could arrive much, much faster. And when we're talking about human spaceflight, speed isn't a luxury, it's a critical safety feature. Shorter trips mean significantly lower stress for the crews, and crucially, way less exposure to the lethal hazards lurking in deep space. Which brings us directly to Section 3, the invisible radiation threat. This is, without a doubt, the darkest and deadliest reality of leaving our home planet. Look,
Once a crew leaves the cozy, protective bubble of Earth's magnetic field, space is actively hostile to biology. Out there, the crew is slammed by a continuous, invisible barrage of solar radiation and cosmic rays. The biological impacts are stark. We're talking severe DMA damage, a drastically increased risk of cancer, and profound organ and brain damage. A sluggish 7-month crawl to Mars using a traditional rocket could easily expose humans to completely unsafe levels of radiation before they even arrive at their destination. This invisible threat is currently the single biggest barrier to living in space, and it really reinforces exactly why those faster nuclear engines we just talked about are so absolutely vital for human survival. Moving right along to Section 4, shielding the human crew. So the crucial point here is, if we're building this network, how do we build the armor to survive the trip? Scientists are actively engineering some brilliant layered defenses to protect humans from these cosmic rays. The primary defenses currently in development fall into 3 main categories. First up, water shields. Water is highly rich in hydrogen atoms, which are incredibly effective at absorbing and scattering dangerous cosmic rays. So, spacecraft can actually be designed where the ship's water supply lines the outer walls of the crew quarters. It creates a literal liquid shield. Second, scientists are testing artificial magnetic fields using superconducting coils. The goal here is to wrap the space hopper in its own magnetic bubble that mimics Earth's natural magnetosphere, basically deflecting those deadly solar particles right off the hull. And finally, for permanent habitats, the ultimate solution is underground bases. Whether we are talking about lunar colonies or outposts on Mars, building habitats beneath the planetary surface uses tons of natural rock and soil as a massive radiation-proof safe harbor. The space hoppers will just act as the armored buses connecting these highly shielded underground hubs. And that brings us to our final section, humanity's cosmic insurance policy. We've talked about the engines, we've talked about the armor, but we really need to zoom out and ask, why? Why undertake this incredibly difficult engineering challenge in the first place? When experts look at the long-term survival of the human race, they all point to one incredibly glaring vulnerability. Staying on just one planet is wildly risky. Just look at the critical threats we face: massive asteroid impacts, runaway climate disasters, global pandemics, or civilization-ending wars. If any one of these catastrophic events strikes while humanity is confined entirely to Earth, it could wipe out civilization. Spreading our civilization across multiple planets, connected by this space hopper network, isn't just about the romantic idea of exploration. It makes human survival mathematically much, much more likely. It is the ultimate insurance policy for our future. But I should point out, it's not all doom and gloom and avoiding disaster. There is a massive, incredibly powerful economic incentive driving this too. And this brilliantly illustrates the point. Asteroid mining could very well create the world's first trillionaire. Once the space hopper network connects us out to the asteroid belt, whole new industries are going to explode. I mean, many of these asteroids are packed with gold, platinum, and ultra-rare metals. Space colonization is going to spark massive new businesses, resource harvesting operations, and yeah, even space tourism. The creation of this infrastructure will completely redefine the global, or rather, the solar economy. We are literally standing right on the edge of a brand new era. The next 100 years could radically change where humans live, work, and travel. Just like airplanes and the internet once seemed totally impossible, a vast network of worlds connected by space hoppers is the next impossible thing that is rapidly becoming real. So, to wrap up this explainer, I want to leave you with this final provocative thought to consider. Looking at all the risks, the unbelievable engine technology we've explored, and the massive opportunities waiting out there in the solar system, if you could, would you leave Earth? Really think about it. Thanks so much for joining me for this explainer. Keep your eyes on the stars and keep learning.